another interesting edition of subjectmath.com. Now, today I'm going to focus my attention on only calculation on this topic, waves. Now, if you need more detailed theoretical explanation on this topic, please watch our video on waves from subjectmath.com. Now let's start. Now we are looking at calculation on waves from UTME, WAEC, and NECO. We're going to do a thorough past question analysis one by one. Let's start with this. The diagram above shows a wavefront in which energy is transferred from x to y in a time of 2.4 times power 3 seconds. What is the frequency of the wave? Now don't forget that frequency is what? Frequency is given as 1 over period. Frequency is given as 1 over period. Now from what we are given, we can't say period in the question, but we can use the given data to get our period. Now we are given how many cycles? 2.5 cycles from the diagram. This is a cycle, from here to where is a cycle, then we have half, 2.5 cycles. And this is the total time taken to complete those 2.5 cycles, 2.5 power minus 3 seconds. Now let's try and get our period now. So to find period, we now say 2.5 cycles, the time taken for that is 2.5 times 10 power minus 3 seconds. Now we need time for one cycle, which is period. So for period, one cycle will give us 2.5 times 10 power minus 3 seconds all over 2.5. 2.5 comes to 2.5. Therefore, my period is, from here, we have 1 times 10 power minus 3 seconds. So this is the time taken for one cycle. Okay, period. Then my frequency will now give me 1 over period, which is 1 over 1 power minus 3. Okay, seconds. That means I'm having s minus 1 power minus 1 as my unit. So I have f is equal to, now in this case I have this one as 1 over period. Okay, so and I have 1, the period is giving me as 10 power minus 3. Okay, so in this case, now I'm going to take inverse of this. So I'm having 1 times 10 power 3. Hertz, unit of frequency is hertz. So the answer is 1 times power 3 hertz. Alright, this is number 2 questions from UTME 2006, number 2. Now, the question says, the frequency of the wave in the diagram is dash, dash, dash. Okay? Now, look at the diagram. What are we giving? We are giving a wave with a complete cycle within 4 seconds. So what is the frequency? Very simple. Now, the formula for frequency here is 1 over period. And period is what? Time taken for one oscillation. Now, for the diagram, the time taken is 4 seconds. So we have 1 over 4 seconds. Okay, and that gives us 0.25 hertz. So the option here is A. On waves is another question, which says a radio station broadcasts at a frequency of 400 kilohertz. If the speed of the wave is 8 meters per second, calculate the wavelength of the radio wave. This is taken from NECO exam 2005, number 25. Now let's solve it. What are we giving? Number 1, we are giving the frequency, which is 400 kilohertz. Now we don't work in kilohertz because the unit of frequency is hertz. We convert by multiplying by 1000 and we are getting 400,000 hertz. Number 2, we are given the speed, 10 to the power 8 meters per second, and this is the speed for every electromagnetic wave. Now, wavelength is unknown, okay, and the formula is V equals F lambda. That is general wave formula, wave equation. Take note, very, very important. So V equals F lambda. where V is the speed, where F is frequency, and lambda is wavelength. We want to find lambda. Let's make lambda the subjects. So lambda frequency is V over frequency. Okay, so lambda is, what is V? Our velocity is 10 to the power 8 meters per second all over. Now the frequency is given as 400,000 hertz. Okay, now if we press on our calculator very well without mistakes, this one is going to give us 7.5 times 10 to the power 2 meters. That is the wavelength of that radio wave. This is another question from WAEC 2000 number 26. A periodic pulse travels a distance of 20.0 meter in 1.00 second if its frequency is 2 times 10 to the power 3 hertz. Calculate the wavelength. Now we are giving the distance as 20 meters, we are giving time as 1 second, we are giving frequency as 10 to the power 3 hertz. Now we have to calculate the wavelength lambda. Now the formula is V equals F lambda. Okay, now lambda at the subject, we have lambda, which is wavelength, is equal to V over F. That is, lambda is V over frequency. Okay, but we are not giving V speed in the question. So using time and distance, we can get that clearly. So velocity is equal to distance over time. Now distance is given as 20 meters. The time is 1 second. So it's giving us what? 20 meters per second. That is your V. So the speed is 20 meters per second. Alright, so which means lambda is V over F and the speed is 20 meters per second and frequency is 2 times 10 to the power 3 hertz. Okay, or per second. And therefore, doing our arithmetic correctly is giving us 1 times 10 to the power minus 7 meters. So, 2 meters. So the wavelength is 1 times 10 to the power minus 2 meters. This is another question from JAM 2019 number 26, which says the distance between two successive crests of a wave is 50 centimeters and the speed 300 meters per second. Calculate the frequency. Okay, now how do we solve this? We are giving what? We are giving wavelength as 50 centimeters. We have to convert to meters by dividing by 100, and is 0.15 meter. And also velocity is given as 300 meters per second. What is frequency? Formula is V equals F lambda. That means I'm making F the subject right now. So F is V over lambda. F is V over lambda. Okay, so now V is given as 300 meters per second, and then wavelength is 0.15 meters. Right, now meters cancels meters. Right, so now if I divide these two, the answer is going to give me frequency as 2000 hertz. Then in a scientific form, and it's 2 times 10 to the power 3 hertz. So the frequency is 2 times 10 to the power 3 hertz. Now let's look at another question. This one is taken from JAM 2019 number 28, which says the diagram above, which is talking of this, shows a stationary wave of wavelength 40 centimeters in a closed tube. The length L of the resonating hair column is dash. You are giving answer A, B, C, D. Okay, now let's start. Now, we are giving the wavelength. Wavelength is 46 centimeters, and we have to find the length L. As you can see, length L of the resonating hair column of this closed pipe. Now, we all know that in a closed pipe, now this one is node, antinode. Now, the distance from node to node, the distance is, you have half lambda, okay, and then the distance from node to antinode is giving us 1/4. Okay, so by the time we add up this, okay, by the time we add this, total distance will give us half plus quarter, that is going to be 3/4 lambda. So that means that what? The length L will give me 3 lambda over 4. Okay, so now already we have been given the value of lambda as 40 centimeters. Just substitute. So our L is 3 times 40 centimeters. Now because we are the answers are in centimeters, we are not going to convert to meters again. Let's say all over 4. So we just do our cancellations and we're going to have 10. So therefore length L is going to be 30 centimeters. Now another question. This is from JAM 1998, number 28. In the resonating tube experiments, if the fundamental frequency of the vibrating air column is 280 Hz, the frequency of the third overtone is dash. Now we are given the fundamental frequency as 280 Hz. We have to find the value of the third overtone, F3. Now, for a closed pipe, we have the following frequencies. We have the F0, we have the F1, we have F2, we have F3, etc. Now, F0 is the fundamental frequency. This is your fundamental frequency, okay, which we are given the question. And then F1 is your first overtone, okay. Then F2 is our second overtone, and this one is our third overtone. We have to find the third overtone, okay, and this one is 3 F0, this one is 5 F0, this one is 7 F0, okay. So for a closed pipe, these are the available harmonics and overtone. This is the first overtone, second overtone, and third overtone. That means we have to find 7 times F0. So that means third overtone is 7 times F0, which is 7 times. The fundamental frequency is given as 280 Hz. So therefore, the answer is 1960 Hz. That is the answer for the third overtone of that closed pipe. Yes, another question from WAEC, year 1997, number 35. It says, a progressive wave has a wavelength of 50 centimeters. Calculate the phase difference between 2 points at a distance of 20 centimeters apart. Okay, now we have wavelength that is 50 centimeters and distance from origin X is 20 centimeters. What is the phase difference? Phi. The formula is phase difference is equal to 2 pi x all over lambda. 2 pi x all over lambda. Alright, is your pi. So let's substitute now. We have phi, phase difference is 2 times pi times, now our x is 20 centimeters and the wavelength is 50 centimeters. Okay, let's cancel. Cm cancel cm, 0 cancel 0, and therefore at last we are having phase difference as 2 times 2 is 4 pi all over 5. That is the phase difference between these 2 points. This is another question. This one is from WAEC 1996, number 37. The distance between two successive crests of a water wave is 1 meter. If a particle on the surface of the water makes two complete particle oscillations in 1 second, calculate the speed of the wave. Now what are we giving? We are giving the wavelength lambda as 1 meter, and also we are giving time for two oscillations, which is 1 second, and we have to find the speed of the wave v. Don't forget our wave equation, v equals f lambda. Now this is also can be written as lambda over period, that is wavelength over period. So we can say v is f lambda or lambda over period. What is period? That is time for one oscillation. So if the first oscillation is 1 second, we can now say time for one oscillation is period. That is going to be 0.5 seconds. Okay, so now have to substitute. So our v is giving us lambda over period. So the wavelength has been given as 1 meter, and the period is 0.5 second. So if we divide these two, that will be 2.0 meters per second. So the speed v is 2.0 meters per second. Another question. This one is taken from WAEC 1988, number 27. A source of sound produces waves in air of wavelength 1.6 meters. If the speed of sound in air is 330 meters per second, the period of vibration is, now we are giving the wavelength as 1.65 meters, we are giving the speed as 330 meters per second. What is the period? Now don't forget your wave equation, v equals f lambda or lambda over period. So we're going to use this one straight. So the v is lambda over period. Okay? Alright, now we have to find period. Okay, so we just put it straight. Now we are giving v as what? We are giving v as 330. Then our lambda is 1.65 meters, is meters per second over period. So what do? We multiply this, and then we have 330 t equals 1.65, right? So the period will give me 1.65 divided by 330, and therefore my period, if I divide the two correctly, we are getting 0.005 seconds. So the period for this function is 0.005 seconds. Question. This one is from WAEC 1990, number 23. A bat emits a sound wave at a speed of 1,650.0 meters per second and receives the echo 0.15 seconds later. Calculate the distance of the bat from the reflector. Right? Now we are given the speed as 1,650 meters per second, and the time is 0.15 seconds. We have to find the distance between the bat and the reflector. Now the echo formula is v is equal to 2s over t. That is, velocity is equal to 2 times the distance all over time. Okay, the time to receive the echo back. So in this case now, we have to make s the subject. So the subject, your s is going to be vt all over 2. Now let's substitute, right? So s is equal to, velocity is given as 1650 meters per second times time. Time is given as 0.15 second all over 2. So by the time we multiply these numbers and divide by 2, our distance is going to be 123.75 meters. That is the distance between the bat and the reflector.